In this lesson, we will look at how and when to use JSON values in relational databasing. Back in the very beginning of Week 1, when we discussed the different types of databases, you may recall that one database type is called schemaless document stores. This is also known informally as NoSQL. MongoDB is an example of a popular NoSQL database that uses the JSON format in each document. These technologies provide flexibility since the structure of the data isn't enforced, but with that flexibility comes a cost. Documents are at risk of becoming out of sync with one another with malformed or missing data. Nevertheless, there are cases where the pros outweigh the cons, and that's why Postgres supports JSON field types. We discussed JSON last week in the lesson on REST APIs. Recall that this is a way of formatting text data for data transfer. There are three ways to store JSON in Postgres: text, JSON, and JSONB. You are already familiar with the text data type. Using this means using a text string that just happens to be formatted as JSON. The next is the JSON type which, like text, will store a copy of the value, but it also enforces that each stored value is a valid JSON format. There are also various JSON-specific functions and operators available for data stored with this. The third type is called JSONB. This one is almost identical to the JSON type, but it has an edge when it comes to efficiency, because it reduces the value to a binary format. This is almost always the preferred option. Every value stored in JSON has what's called a path, describing its location within the JSON object. Recall that JSON objects come in two flavors: arrays and objects. Similar to Python dictionaries, objects have keys for each value. Similar to Python lists, arrays have indexes for each value. Using these two accessor methods, we can describe a path to any value within JSON. For example, in order to get the value sunflower seeds out of the object shown here, we need to key into the title field. What if that same JSON object was placed inside an array as an array item? As in a Python list, the first item in a JSON array has an index of 0. So in order to get the value of sunflower seeds, we need to first index into the 0th element of that top-level array, then subsequently the title key of the object inside it. In this last example, we have an object with a nested array of objects. In other words, an object containing an array which in turn contains an object. In order to find the value sunflower seeds, we must follow the path of keys and indices through artwork, 0, and title. There are a few different ways to access values in JSON fields, using what are called JSON operators. Note, these will only work on fields that use the JSON or JSONB data types. The first is to use a hyphen followed by a greater than sign. If this is followed by an integer, it will attempt to index the JSON as an array. Otherwise, if it is followed by a string, it will attempt to key into the JSON as an object. The third operator looks similar but uses a hash symbol instead of a hyphen, and it accepts a JSON path as its argument. If no value exists at the path location, this operator will return null. Otherwise, it will return the value corresponding to the given path. Conveniently, each of these will automatically convert the JSON result into plain text if we use two greater than signs instead of one. These are the most common operators, but the Postgres documentation describes many other that serve niche use cases, such as checking to see if a value exists, or merging two JSON objects. In this table, we list some functions that help us work with the JSONB data type. We've chosen these since JSONB is the more efficient preferred data type. But if you ever need to work with the regular JSON type, there are other functions that Postgres provides for those use cases as well. The first function we will look at is named JSONB object, which is used to create JSONB values, and it has a few variations. The first accepts a list of alternating key value pairs. For this to work, the list of inputs must be of even length, such that the even indexed values serve as keys for the odd indexed values. The second variation accepts a list of lists such that each inner list consists of key value pairs. The third variation of the JSONB object function accepts two lists, the first being a list of keys and the second being a list of values. These lists are taken pairwise in order to build a JSON object. All of these variations are functionally equivalent, but one syntax may be more convenient than another. The next function we have is called JSONB array length. This function will return the length of a JSON array as an integer. Another utility is called JSONB strip nulls, which will eliminate any object for which the value is null. It performs this recursively to handle nested values as well. However, it will not remove null values from an array. The last function we have is called JSONBPretty, which returns a friendly formatted representation of the JSONB value in the text field. All of the new syntax may feel overwhelming, but in an exercise that follows, we will demonstrate how to work with these data types in real SQL commands. The use of JSON in relational databases should generally be reserved for special cases. For example, if you need a field to serve as a kind of bucket to hold generic data of any type, JSON may be a good choice. Another case is integrating with other services that use JSON, and for which converting their JSON data into SQL is inconvenient or unnecessary. Lastly, if there is a need to co-locate data that would otherwise span many tables, JSON can help avoid that complexity.